Well, today we are going to look at sigma notation and series. Our learning targets are I can find the sum of a series defined with sigma notation. So this little guy right here is sigma. And I can write a series using sigma notation. So yesterday you talked about sequences. A sequence is just a list of numbers with a pattern. Okay, and notice they're all separated by commas. Right, that's a big thing. Well, today we're going to talk about series, and a series is just a sum of a sequence. So it takes that same list of numbers, and instead of just listing it, it adds all those numbers together. So plus signs in between versus commas. So mathematicians have a little shortcut for this. They use the Greek letter sigma, and this way they don't have to write out that long list of numbers added together. They can use this nice little notation, and I'm sure you've seen this notation on any math movie or commercial or anything like that always tries to scare people away from math. But anyways, let's look at the parts of the sigma notation. First of all, we have this Greek, why is it not appearing? This Greek letter, which means sum in mathematics. And the other important part is we have the formula to find each term to add. So this was what you talked about with the explicit formula, getting an explicit formula to represent the pattern. And then we have the I equals 1. It could be anything. It could be I equals 5, 2. That just tells you what the first input value is. And then the last number there at the top is the last input value. So if we want to expand this guy out, we just simply look at putting the 1 in there. So we just do 1 cubed minus 1, because the first I is 1. And then we add it, and then we do 2 cubed minus 1. And then we do 3 cubed minus 1. And then we do 4 cubed minus 1. And then we do 5 cubed minus 1. And once we put the i's in there, then we just simplify them. So I just grab the color here. 1 cubed minus 1 is 0, so I've got 0. 2 cubed is 8, so minus 1 is 7. 3 cubed is 27, so minus 1 is 26. 4 cubed is 64, so that's 63. 5 cubed, 125, so that is 124. Right, 64 and 125. And then we just add these all together. And if I add 7 and 63, that's 70. And 24 and 124 gives me 150. And that is a total of 220. All right, so that is how you expand and find the sum. All right, let's look at another example. So this one, I'd like you to stop the video and figure out the answer and then rework the video so that you see if you're right or not. All right, let's check your work. Now, the big thing here is I'm starting at this 3. So I put -1 cubed over 3 plus -1 to the 4th over 4, -1 to the 5th over 5 plus -1 to the 6th over 6. And so this becomes -1/3. If you take a negative to an even power, it becomes positive. And so that is the expanded form of the sigma. And then if you add it together, you get -760, or approximately -0.0117. All right, let's look at the next video. Now we have a series that is expanded, and we have to write the sigma. So instead, I now have to look at my big E, and I've got to figure out what goes here, what goes here, and what goes over here. All right, so I first start with my explicit formula. What's the pattern? What's going on? So 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed plus 6 cubed plus 7 cubed looks to be the pattern. So what that means is that my I is just being cubed. And I'm going to start at I sub 1 because that's the first I that's cubed. And then I'm going to go up to 7. If you can read that. And that's all you have to do for this one. All right, take a look at the next example. Pause the video and see if you can't come up with the answer here. All right, let's check how you did. So the nice thing about this one is they have the pattern already given to you, right? The formula is right there, 3 to the n minus 1. And if we look at it, we can see that it seems to work out just fine, right? So if I stick 1 in there to start with, I have, I'll just write this, 1 over 3 to the 1 minus 1, which is the same thing as 1 over 3 to the 0, which is indeed the 1, right? And so how many terms do I go up to? Well, it looks like I go all the way up to n terms. All right, that is the rest of the video. So ask yourself how you're doing on finding the sum of the series defined with sigma notation and being able to write a series using sigma notation. We'll have questions for you later. Have a good day.